Hey, what's up guys, my name is Zaibi, and in this video we're going to talk about compression method, specifically the Huffman coding method. Okay, so first of all, what is Huffman coding? Huffman coding is a compression method that is developed by David A. Huffman, and it is a compression method that is commonly used for a lossless data compression. So if you want to do data compression without losing any of the details in your data, for example like text, you don't want to lose any of the details in your text since that would be a real messed up thing to do, and Huffman coding is the perfect technique or the perfect method for your compression since it could reduce the size of your text but it doesn't lose any of the details of your text when you decompress it. Speaking about text, let's jump for an example on how to use Huffman coding method on text data compression. So for this example, I will take the example based on my own name letter, that is Zaibi Agusta Hidayatullah, and I'll remove the spaces characters just to make it easier. After that, we need to group each unique character with how often they're being used in the text, or you could say the frequencies of each word. Then you need to arrange those groups of characters based on their frequencies from lowest to highest. Now, take two characters with the smallest frequencies, connect them together, and make a new node with the sum of those two frequencies. After that, you just arrange them again based on their frequencies, and repeat, so on and go on until you create some kind of tree that we call the Huffman tree. So, how do we create the 1-0 code using this tree? Well, it's quite simple at least. If it goes right, then the code is 1, and if it goes left, then the code is 0. For example, here we could see that the code for Z is 1010 since in the tree we can see that the path to Z is right left right left. Now, if we compare the Huffman code with the ASCII 8-bit standard characters, we can already see that the Huffman code takes less space than 8 bits. Well, at least most of them, since some characters might take up more than 8 bits, but that's okay, since they're used less often than the others in the text. And of course the opposite, the more often the character is used, the less space it will take. Now, if we see the final size comparison between the original 8-bit size and compressed size, you see that the Huffman method did its jobs perfectly. It already compressed my name text from 192 bits to 83 bits. That's more than half of it. Well, correct me if I'm wrong if there's any false information in my explanation, but that's it from me in this video. See you next time.